Good afternoon, everyone. I'm Nikesh, and I'm thrilled to present the demonstration of our project Use of Deep Neural Network in Garbage Fullness Determination with my fellow team members Abiral, Laxman, and Pradeep. The IoT device in our system is fixed on top of the container as shown. Some changes had to be made in the system's configuration for demonstration purpose. For example, the IoT device, instead of sending the image of the container every 20 minutes, which we intend to do once it gets deployed in the real world, now just sends it every 2 minutes for the sake of demonstration. Also, the incremental learning with new image data is scheduled to take place every 10 minutes. And it is assumed that the system is just starting up and there are no prior images of the container, so the 4 most recent pictures which we intend to show for a container is not shown in this demonstration at the beginning. Now we begin trial 1 where we have an empty container. The IoT sends top view image to the server for processing. A web application has been built which has the overview of the container with its location on a map. It shows the current status and shows containers which are full. The app is scalable in a sense that it is designed to support multiple containers at the same time. Also, the app is integrated with the server through WebSocket, which allows real-time updates of the container's information. Right now, there are no active devices yet. As shown previously in trial 1, we send the image of an empty container and hence we just show the updated view which shows that the container is empty. On clicking the container icon, we see the container's info with container's identifier and its current fullness level and also its image. We now begin trial 2 where we have a half full container. And just like before, the container's status gets updated in real time. The new image of the container is also seen in the container dashboard. Finally, we begin trial 3 with a container that's filled up to the brim. And just like before, we see the status get updated to full. This time, however, an alert also pops up to show the list of the containers that are full. The container icon is also shown red in color. The system is scheduled to update the neural network with the new images which the model could confidently predict. This allows the system to be better over time and more efficient in recognizing the fullness level accurately, irrespective of the type of trash or environmental conditions. So after the scheduled time, which is 10 minutes for this demo, the server runs a script which fits the new images to the existing model in a separate thread. 3 images which we just took have been loaded. 20% cross-validation split does not work as there are too few images. This incremental training process does not cause the server to be irresponsive to the incoming HTTP requests. Also, after the model is updated, the new weights of the model can be immediately used, so there is no need to restart the server for the new trained model to take effect. And here is the time series data of the 3 images stored in a CSV file. Provided that the system gets to operate in the real world long enough, the data collected can be of a serious value for conducting forecasting analysis of container fullness and studying patterns and trends. Thank you for your time and attention. It has been a pleasure sharing our project with you, and we look forward to suggestions and answering your questions.